This is Mr. Craig, and this is the second video in the Helping to Name Compounds section. In this case here, we're actually going from the compound name to the chemical formula. First thing I want you to recognize is that we have nitrous acid in number one. Nitrous acid, since we have an acid, that means that we're going to start off with a hydrogen. So anytime that a compound starts off with an H or hydrogen, you're looking at an acid. Also, what I want you to notice is there's no hydro in the name. So there is oxygen in this compound. The OUS ending in nitrous indicates that we have a polyatomic that ends in ITE. So the ITE ending indicates that we have nitrite, which is NO2, because nitrate is NO3. The nitrite has a -1 charge, the hydrogen's +1. We're good to go. Excuse me. Heptene is one of the organic compounds that I want you to memorize. It ends in ENE, which means that we have twice as many hydrogen as we do carbon. That's our generic equation for the ENE endings, or the enes. Since we have heptene, heptene deals with 7, so we're going to have 7 carbons. And if we're doing twice as many hydrogen, then that means we have 14 hydrogen. So heptene is C7H14. Manganese 4-phosphate is an ionic compound, and it has a metal that has more than one charge. In this case here, the Roman numeral tells us that we have a certain charge on the manganese. Manganese can have multiple charges, but we only care about the +4 in this scenario. So we're going to write out the equation where we have manganese that has a +4 charge. Also, we know that phosphate has a -3 charge. So if we need to balance out the charges. So if I know phosphate is -3 and I know manganese is +4, that means I'm going to need 3 manganese ions to balance out the charge on the nonmetal, which in this case is phosphate. Also, since I have a +4 charge on the manganese, that means I'm going to need more than one phosphate. Therefore, I'm going to put the phosphate in parentheses. Phosphate ion again is PO4. And since the phosphate has a +4 charge, the manganese has a +4 charge, the phosphate has a -3. To balance this out, I am going to need 4 phosphates to totally balance this compound out. So my final formula is Mn3 parentheses PO4 outside the parentheses 4. Manganese 4-phosphate. Looking at calcium nitrite, and have another ionic compound. Calcium has a +2 charge. Nitrite, it's a polyatomic because it ends in ITE, where if it ended in IDE, you're looking at an element. Also, the ITE ending indicates that we have one less oxygen than the nitrate. So we're looking at the NO3, actually NO2 for the nitrite. Also, the reason why I put parentheses around the nitrite is because calcium has a +2 charge and nitrate has a -1 charge, as does nitrite. So I need 2 of the nitrite ions to balance this out. So our final equation should be Ca parentheses NO2 outside the parentheses 2 for calcium nitrite. In number 5, we have zinc acetate. Zinc has a +2 charge. Acetate, a polyatomic because it ends in ATE, has a -1 charge. So we need to use parentheses again, and acetate is one of our 10 polys. It's C2H3O2. And again, since the zinc has a +2 charge, the acetate has a -1 charge, we will need 2 acetates to balance this out. Looking at example number 6, we have lithium hyposulfite. The hypo means that we have 2 less oxygens than the regular ATE ending. So lithium has a +1 charge. Sulfate, SO4, has a -2 charge. The hyposulfite, which has 2 less oxygens than the sulfate, has a -2 charge total, so we're going to need 2 lithiums. Now the hyposulfite We do not need to show parentheses for this, since we only need to show one hyposulfite. So again, sulfate, SO4 with a -2 charge, hyposulfite means that we actually have 2 less oxygens, however the charge remains the same. So lithium hyposulfite is Li2SO2. Aluminum iodide, Al, and the charge on aluminum is +3. And iodide, since it ends in IDE, means that we're looking at an element, unless it's hydroxide. So if it ends in IDE, you're looking at simply a single nonmetal. And the charge on aluminum, which was indicated earlier, is +3. The iodine has a -1 charge. So to balance these charges out, we'll need 3 iodines. What I want you to recognize is you'll never have 2 I's together in a chemical formula. So this is aluminum, and then the iodine follows immediately after that. Alright, looking at number 9, we have tetraphosphorus octanitride. So we have a nonmetal with a nonmetal. We know that we have 2 nonmetals here because we see Greek prefixes. So tetraphosphorus means that we have phosphorus, and the tetra means that we have 4 of those. And the nitride simply means that we have nitrogen. The octa means that we have 8 of those. We do not care about charges. That's why the Greek prefixes are listed on here. Ammonium bromide. Ammonium, even though it is a polyatomic, which is made up of strictly nonmetals, it does have a positive charge. And ammonium, NH4, has a +1 charge in this case. Bromide, which is bromine with the last part of the name changed to IDE, also has a charge of 1, but in this case is negative. So the ammonium bromide is a +1 to -1, so it's a 1-to-1 ratio, and we do not show parentheses anywhere on this. Iron 3 carbonate, we have an ionic compound, and we have a metal that has more than 1 charge, and I've indicated that charge for you in this case. Iron has a +3 charge, and carbonate, a polyatomic ion, has a -2 charge. So that means that we're going to need 2 irons. And then the carbonate, we're going to need 3 of those to balance out the charges here. So when we finish with this, even though there's a 3 on the outside of the carbonate here, that has nothing to do with how many we have. So if we need to represent more than 1 polyatomic, you must show parentheses. Okay, just showing the CO3 doesn't tell me that I have 3 carbonates. In this case, I have to use parentheses and put the 3 on the outside. So iron 3 carbonate looks like that. Pentane. Notice that we have an ANE ending, which means that I have carbon. It's a carbon-hydrogen compound. If it ends in ANE, that means you have twice as many hydrogens as you do carbons, but we add 2 more. So in this case here, we have pentane, which is 5, the hydrogen, which is twice as many carbons, plus 2. So in this case here, we're going to have 12. So pentane is C5H12. Make sure that you know the ANE endings and the ENE endings. And there are actually 19 of them because there's no such thing as methene. Alright, number 13, mercury 1 hypophosphite. Mercury, the symbol is Hg. It has a +1 charge. The hypophosphite, we have phosphate within here, okay, but it has an ITE ending and hypo, which means that we're going to remove 2 oxygens from the phosphate ion. Phosphate has a -3 charge, and the hypophosphite also has a -3 charge, which means that we're going to need 3 mercury ions here. Now the phosphite, or hypophosphite, simply means that we've removed 2 oxygens from the phosphate. The charge stays intact, still has a -3 charge, and we're going to have only 2 oxygens. Again, no parentheses are needed for this, since we need to show more than 1 metal and only 1 nonmetal. So mercury 1 hypophosphite is Hg3PO2. Sulfur hexachloride, we have a nonmetal with a nonmetal. We know this because we see a Greek prefix here. Also, we know that sulfur and chlorine are nonmetals. So sulfur, since it does not have a Greek prefix, and we would not use mono, we only have one of those. And then hexachloride, the chloride indicates that you have chlorine, and the hexa means that we have 6 of those. And again, we do not care about charges when it comes to nonmetals with nonmetals. And then the last one, number 15, we had titanium 3 chromate. Titanium is Ti, and it has a +3 charge. Chromate is CrO4 with a -2 charge. So if titanium has a +3, chromate has a -2, then that means that we're going to need 2 titanium ions to balance this out with the chromate, which is CrO4. And again, it ends in ATE, so that means that we're going to have 4 oxygens here for our chromate, which is no different. And let's balance this out. Since titanium has a +3 charge and chromate is -2, that means that we need 3 chromates. I hope this has helped you in naming the or writing the formulas from the chemical names. I highly recommend that you go and look at the tutorials and do more practice. I have over 400 examples on one of the tutorials, and it does cover acids, it covers the metals, the nonmetals with nonmetals, as well as a lot of the ionics. However, it does not have the ANEs, the organic compounds on there yet. So please, if you need more practice, go and check those out.